so when I was a kid, this is all I knew about mushrooms. This is a white field mushroom, and it's what we used to have in our fry-ups, and for years, that was it. Now, courtesy of all the cookery programmes on British TV, and I believe there are so many because they're cheap to make, there's a whole other family of mushrooms that I now understand you can eat. So we've got these things which are chestnut mushrooms, shiitake mushrooms, oyster mushrooms. There's just this range of mushrooms that have been introduced to people, and you can eat them. And before that, I would only ever eaten that one and looked at this kind of stuff with great suspect because of what we think of mushrooms are. But it turns out there's something like 1.5 million species of mushrooms and fungi out there. That's 6 times more than all the other discovered plant species. Of those 1.5 million, only about 20,000 of them produce a fruiting body, which is what this is. It's the bit of the mushroom that we can see. The rest of the mushroom is actually underground. They form a network of roots. These roots are called mycelium. Now, underneath the ground there are so many mycelium that they reckon in every footstep you take, there's something like 300 miles of mycelium. That's just crazy. These mycelium form a network, a dense network of interconnected nodes. And in 1 square metre, there are more nodes than there are in the internet. Across the entire Earth, there are more nodes than there are in people's brains. And these nodes and these networks are able to communicate with each other. They communicate with each other in the same way that our brain does with electrochemical systems. They also link trees to each other, allow trees to communicate and all that kind of thing. And every time you find out something about a mushroom or a fungi, it's an absolutely astonishing fact. Now, of course, we've dealt with these for most of our lives and most of our history as a human species, but it's always been limited to basically 3 things. That is food, medicine, and recreational drug use in the form of magic mushrooms. And that's really our everyday contact. And as I say, when I was a kid, my everyday contact was that thing. It's all we know about them. But when we start to look deeper into them, then they are truly astonishing. Now, that, which is a bit more of a whole earth attitude, coupled with a move away from extractive technology, because what we used to do with this stuff obviously is go and grab a plant, see what it might be useful for, and then extract the hell out of it for the useful component that we were looking for. And that's still done to a degree, because of course these things split up into families, and there's one whole family called Decomposers, and that's the things we use for beer and cheese and wine. But because they will decompose any hydrocarbon, the enzymes they produce will also decompose oil spills. But there is a big move away from that extractive technology to working more in conjunction, and this is where the mycelium come into their own. And most plastics aren't in fact virgin plastics, they're quite often composite materials. If you think about glass fibre, it's a composite of a resin and a fiberglass, and that makes the plastic. And most plastics are like that. They use a large proportion of filler to make a composite material rather than using the entire virgin plastic all by itself. Now, when a mushroom or a fungus grows into a material, and here we're talking about things like wood and sawdust and rice husk and all that sort of stuff, then the mycelium penetrate that in a 3D network, and that 3D network joins up. And the mycelium are protein strands, and actually protein strands that when dried are stronger than silk. And as they penetrate that material and form a 3-dimensional network, they effectively glue everything together. They make it a solid lump or a composite material. So it's the Dutch who are really into this. It's the University of Utrecht where they're doing some of the really basic science. And what they're finding is that just the growing conditions can change the nature of the mycelium that they grow into things that are going to be hard plastic-like, or they can be rubbery, or they can be like cork, or they can be like wood, or they can be like paper. It's astonishing how many replacement materials can be grown from a mushroom by changing slightly the growing conditions. And it has been put into practice. There's a designer called Eric Clarenbeek, and he produced a 3D printed chair. What he did was print the mould out of a potato starch based plastic, filled it with a mushroom organic mix. I think he used straw, allowed it a couple of days to grow, and then cooked it in an oven. And the oven cooking kills the mushroom, dries it out, and fixes everything in place, which means there's no risk really of species contamination if you were to post this around the world, because basically the mushroom is dead. And the really cool thing about this material is it's lightweight, it's strong, it's fire resistant, it's water resistant, and it's been taken up by another company called Excavative. Excavative are using this technique to produce materials for packaging. Packaging is one of those almost shameful uses of plastic where we are deliberately making something that is designed to be thrown away and to go into landfill and does not decompose. So Excavative have tackled that, and they're making packaging products that are better than the plastic, and yet you can just put into your garden at their end of use, which is essentially when you receive them. So it's a much more encompassing vision of what plastics in this particular use are. Excavative go on the idea that they're using fewer resources, they're using less energy, they've taken account of the end of life. They argue about the life cycle of plastic development, how basically it came from milk, went to oil, and the future is going to be in mycelium. Now, it's not only in these areas that you're looking at. When you're thinking about a company like Mediamatic, for instance, who are trying to promote this idea and involved in growing shoes, which I thought was super cool, it is also entering the space race. Now, the space race, one of the greatest problems with it, of course, is space debris. There are some astonishing facts and figures about space satellites. When I think about space satellites, all I really think about is Sputnik and the International Space Station. That's about it. But there are 6,900 satellites flying around there above our heads, of which only about 4,000 are functioning. The rest are just zipping around waiting to fall back to Earth. And this is the space debris, the space junk that NASA is really worried about, because these things zip around at something like 16,700 miles per hour. That's faster than a bullet. And of course, when they break up a little bit, those big bits that you can see, and remember your average satellite is about the size of a washing machine, they get into little bits that are still zipping around like nuts and bolts and pieces of metal. And they hit other satellites at something about, I think it's 520 collisions per month. These break off little more bits that continue to zip around and lead to something called the Kessler syndrome. So a little bit hit a big bit, knock off loads of other little bits, they zip around and hit more satellites, and they create more little bits in orbit hitting more satellites, and so you get this rolling effect of things. Now, the launch rate of satellites is going up exponentially. SpaceX have got this plan for a mega network of satellites that we can have to use the internet, as does Amazon. SpaceX are launching batches of 60 at the rate of 300 per month. That's astonishing. And they plan to build a network of 12,000 mini satellites. Amazon are planning its own network of something like 3,260-ish mini satellites to create their own internet broadband service by a network of satellites above our heads. So satellites are crowding the space, and of course they're tremendously expensive. They just hang around there, they don't break up particularly well, and they don't decompose. Using the techniques of Utrecht and the things that have been discovered on making composites using mycelium growing through wood and straw and that sort of stuff, there are now experiments to build satellites out of fungus. So this material is being looked at to replace plastic in a surprising number of ways. From the kind of homegrown thing that we think about to space satellites. Anyway, I thought I would share that idea with you because lots of people are interested in bioplastics, me included, because of their renewability, their sustainability, how we can actually use them in life so that we don't destroy our planet, but more work with it. And this is one field that is surprisingly active and extraordinarily interesting, because it does pull you into things that you would think just weren't possible. Turns out they are. Anyway, I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.